have invited two scholars here, one from mechanical engineering and the other from civil engineering. They will share with you how the experimental study is conducted in their area, what were their independent variables, like that, so that it gives you more clarification how the experimental studies are conducted in science and engineering. So our first presenter is Mr. Sukhdev Singh. He is faculty in CCET college here in Chandigarh, and he is also PhD scholar in our institution. So I won't take time much, and I request him to share with you his experimental method of research. Thank you.
Thank you, ma'am. Good morning, everybody. My name is Sukhdev Singh. I am research scholar at NITTL in the Department of Mechanical Engineering Department and lecturer at Chandigarh College of Engineering and Technology. Today I am going to discuss my some part of my research work. Okay. PPT कहाँ से आएगी?
सर पेन ड्राइव
सेव कर तो ये ठीक so experimental research in mechanical engineering with the help of design of engineering, you can optimize your product or a process. It is a you can say it is very powerful statistical tools in which you can design your product or you can design your study by giving at 2-level factorial screens or general factorial studies or response method, surface methodology, mixed design techniques are there, and combination of two factors. What are these levels are there? Basically, I am doing my work by using design expert experiment in which these options you can be opted for. For example, 2-level factorial screening in which it can this type of study your product and process you can identify your factor which can affect your process and product, and you can make a breakthrough improvement. What is the 2-level? I have discussed about that. If, for example, there are 4 factors are there: temperature, pressure, concentration, stirring rate. These are the factors are there, and it has 2 degrees. One is maximum level, second is high level. Low level, second is high level. For example, temperature maximum level or high level is 35 degree and low level is 24 degree. So it has two level factorial problem is there. And if it is 3-level, for example, in my case, yeah, in case of mechanical engineering, in case of CNC milling, 3 factors are there. Cutting speed is there, feed is there, depth of cut is there, and I have selected 3 levels. One is minimum level, one is maximum level, and one is middle level. So I have 3 level, and in this type of problems we can say that this is 3-level factorial problems. So design of expert DOE, it can provide us the it can optimize the process which is of 2-level or it may be of 3 levels. So in 2 levels you can say you can identify the vital factors which can affect your process. In that case, in the second, you can factorial or discover the best combinations of another factors, such as what are the source. For example, I have taken this type of study, source versus the supply of raw material of any study. This type of problems can be solved through this software. Then another method, this is known as response surface method, which is almost used in every you can say mostly use this type of RSM method used in every experimentation work. This will give you the optimal process setting to achieve the peak performance, so that your responses can be filled up or your responses can be seen on the surfaces. Then there mixed design techniques are there, which can discover the ideal recipe for your product formulations. There can be combination of RSM and other type of techniques. Then combination of process, this is like that you have to mix your cake with different ingredients, then bake it too. So this is the general study what about the DOE gives these type of experimentations, yeah, these type of options in this program. So this is one that is I have already explained what is 2-level factorial design and what is 3-level factorial designs. So this is I have made a general DOE process chart in which it can you can see that first you have to define your objectives and what are your measurable responses in your experimental work. Define objectives means you have to clear what are your objective. For example, in my case, yeah, in my research work, my objective may be minimization of surface roughness and tool vibrations in CNC milling machines. So this is my objectives. And what are the measurable responses? Responses are that in which your objective can be effect. So my objectives, my measurable responses are the most important two things. Number one, surface roughness. Second is tool vibration. There may be some other variables like my tool life is another type of responses may be there. So these are when you have to clear about your objectives. These variables can be find out through brainstorming sessions or fishbone diagrams on any other type of you can select the variables. Then you have to input your data by giving these are the some type of mixture worksheets are theirs and design selections, or combine the design work and then go to directly to the residual analysis. Otherwise, input stage, then you have to go for the stage for factorial worksheet and give the selection. Then you have to give through RSM design, then residual analysis. Then you have to optimize your product work for to achieve your objectives. So this is the general layout or the flow chart in which every DO process must be followed out. I have lay out some of the design work in bullet forms. For first thing, when you have to design your experimental work, it is these are the check sheet like that. You have to define the object of your experiment, then you identify your responses, how they can be measured, you have to know that. Then you have to decide the variable to investigate. Third, then you have to choose the lower level and higher level of each factor so that we can estimate the difference generated in the responses. That difference is known as delta. That value is known as delta. So then you have to select your design, be specific, block your known, if there are some variations are there that can be filtered out, or then you have to make the design. Next step that is you have to choose the model from which the subject matter of knowing the relationship between the factor as well as the responses. Then you have to evaluate your design, then go over the design for physical setup and design execution work, determine how to hold the non-DOE variant constant, identify your controllable variables, can they be monitored or not, and establish the procedure for running an experimental work. Then you have to negotiate time, material, what are your budget constraints are there, you have to what expenditures you have to invest or not. Then to discuss any other special consideration for this experimental with management. Then you make up your plan for studies, and then you have to perform your confirmation test. So before starting the DOE planning, these are the 4 major steps which will guide you how to appropriate the factorial design based on your signal to noise ratio. Signal to noise ratio, as I have defined you first, this is the 4 step. One, you have to identify your opportunity and define the objects. Second is to define the change delta y, which is to detect, that is your signal. And second is to estimate the experimental error, that is sigma, that is known as noise. And this signal to noise ratio is used to estimate the power of your experimental work. This is very important step. You have to estimate it. Then you have to select the input factor for the study, and then the design for your factorial work. For example, I have given some of the one example here to how to um, calculate, how to study your estimate your power of your experimental work. For example, I say determines how many runs you need to achieve at least 80% chance power for revealing an acting signal of delta. Okay, so that means this is you can say the journal, this is your say, or this is your, I can say ki what is one of the example is this, what is the ideal color or type phase combination to maximum the readability of video display terminals. The factors are foreground black and yellow, background white on gray, or typeface Arial time Romans. So a typically or any other say 2 raised to the power 3 design in which 8 run is set up to minimize the time needed to read a 30 word paragraph. So I says in this particular example, a 1 second improvement is the smallest value around the interest from the client. That means this is our signal. Delta is equal to 1 second. A prior DOE reveals that standard deviation of 0.8 second is in readings. That means our noise is 0.8. So the ratio of this signal to noise ratio is 1 divided by 0.8. It will gives you 1.25. That means we want to detect whether it to be at least 80%. Okay, so how will we have to do that? This is the design expert. When you have to enter that, this will give you how the responses are to be filled in that particular series. For example, in this case our signal to noise ratio is 1.25. when we have to give the response 1 and find and give it the time in second and signal 1, and noise ratio, signal to noise ratio is 0.8, it will give to 1.25 ratio. It will show us that probability of detecting 1 second difference at 5% alpha. That means if you can go for a normal curve, 95% confidence, our power is only 27.6. That means only 2 raised to the power 3 or 8 run is not sufficient with to get the desired power of 80%. For what we can do that, for we go back and block the second replica in which it will give the power, and it will power go up to 62.5. 62.5%. This is also not a good enough. Then we have to give for the third replica block to the design. It will give us 24 run practicals, and when we have to evaluate it, it will give us the 80% chance for the ratio of 1.25. So this is how we can calculate the minimum number of experiment required for any design by using the signal to noise ratio. So this is one of the very important factor in deciding the number of experimental work in every work. So this is now I come to my research work. I have did the minimization of surface roughness and tool vibration in case of CNC milling operations. So in this case, so my objective is very much clear in my topic. I have to minimize my surface roughness and tool vibrations, but there are some other variables are which can affect when I have to minimize the surface roughness and tool vibration. It can affect my tool life also, which is not my objective in this study. So what can I do? How I have to perform that? I have taken the workpiece. I have chosen this tool die steel EN31, which has the following composition. These are the standard composition of my workpiece material, and I have done it on the CNC milling machines with 2-bit uh, tungsten carbide insert. You can see that this is my tool holder in which two inserts has been inserted to for my milling operations. And this is my cutting conditions. What are the cutting conditions? These are basically my input parameters are there, variables are there. These are the variables which can affect the my this to achieve my objective of minimization of surface roughness and tool vibrations. So these are the cutting conditions are there. First one is cutting speed. This is my first variable. Second is feed during the work. Third is of depth of cut, and fourth one is environmental. Environmental means whether I doing the dry machining or any other type of machining. So for EN31 tool die steel, and from the machine tool design data book, the appropriate cutting speed I have taken 100 to 180 meter per minute, and feed 0.1 to 0.2 mm per tooth. The depth of cut is approximately about 0.75 to 1.25. This is these are the data from the I have taken from the literature work as well as the machine tool design data handbook. So this is the control level of the control factors. So I have gone for three levels. One is low, one is medium or middle, then is high. So cutting speed, for cutting speed, highest lowest speed is 100 and maximum speed is 180, and middle is 140. Again, tooth feed is 0.1 to 0.2 and middle is 0.15, and in case of depth of cut it is 0.75 mm to 1.25 and middle is 1 mm. So this is the factor, these are the control factors, these are the input factors which I have to choose in from the literature work and design data books. So this is the this is the 3-axis vertical milling machines. This is installed in the Department of Mechanical Engineering NITER, on which I have experimentally did my work. So how to measure the surface finish? Surface finish, I have taken this a Mitutoyo surface roughness tester, on which the this is a portable type of tester is there, which is you can directly mount it on the workpiece. So I have measured the surface roughness after each cut on the workpiece at the 3 locations, and the measurement was done in the micron, and average of these 3 readings were recorded accordingly. So then this is another type of machines of this is a machine vision system of SIPCON. This is also a new machine on which is used to observe the you can say the flank wear of my cutting tools. So flank wear or the tool life of my cutting tool is observed when when to attain the flank wear of 300 micron. 300 micron, it is an standard terms from ISO standard for conducting the tool life or testing the tool life of end mill test. So this is the type of machine on which I have measured the flank wear. You can see that I have made this type of arrangement on which the insert can be fitted down and this image can be enlarged on the this monitor from where I can measure this flank wear of micron. This will give us the accuracy in case of 1 micron each. So this is very good machine. And third one is to capture the vibration amplitude of tool. So for that one I have attached an accelerometer, 3-axis accelerometer of National Instruments. This accelerometer I have attached to the spindle of my CNC machines, which is connected to a desktop having LabVIEW software through this CRIO. This is the chassis for making this one to capture this vibration amplitude, and it's this amplitude was given in term of accelerations. That is, what are the amplitude, what are the vibration I have measured. This is given in meter per second square. The signal it will deliver, that is captured in a computer, and that signal can be used to measure the or to in my experimental work. Then how, now after deciding my input factors, what I where to do the experimental work, now the next step is to design my experimental work. So the experimental work done I have done on design expert software. Sorry. So when you have to select that experiment, double click on then. So this is the first screen you have to find out, on which by clicking a new design you can go for select your design work. So this will give you, now when you can see that there are 4 factors are there. One is factorial, second is response surfaces, third one is of mixture, fourth one is combined. Basically this is what is, these are the type of the factorial designs you can design it out. This is, in this case, this is, you can say that 2-level factorial design. This is again given 2-level minimum run. So this is the how to design your work, or what are the design you have to chosen for. So for my work I have chosen the response surfaces methodology, and under response surface methodology I have chosen the miscellaneous as an my design work. Miscellaneous, it will give us the 3-level factorial in which approximately 27 experiment he has decided about. So this is the, when you have to put your data into that into that screen, it will design your experiment for in the coded form. Coded forms means if your speed is uh, -1, -1, -1, that is the lower speed, and feed and depth of cut. And in terms of actual factors, you can see that this is your first experiment, speed is at 100 and feed and depth of cut. Now you have to do the experimental work as the design of experiment gives you the 27 runs about that. After doing that, after doing that type of experimental, that first experimental 100 meter per minute at the feed of 0.1 depth of cut, I have find out what is my surface roughness, what is my vibration amplitude, and what is my tool life at that particular setup. And ultimately I have go for 27 runs and recorded all the values of surface roughness as well as the vibration amplitude as well as the tool life of 27, and these values has been recorded in our design experimental work. design. After, when you have to submit your data into that software, it will give you for first one, when you have to go for, it will go for interaction with that. You can see that on the left hand side of your transformation option has been appear in the main window. When you have to go for that, it will gives you that your transformation as a none. That means your this is already given by the software key that no transformation is required to your data, or otherwise it will give you the square root or another type of natural log and other rot which have they have decided it out, you can do for that. Then the next experiment, it was given that this is the fit summary scale. Fit summary will give you the option for which type of equation of the data is best suited for your data. For example, in my case, it is suggested for surface roughness. First I go for the surface roughness only. For surface roughness, it will give me the quadratic terms. For example, this is another sources are there, linear, 2f, cubic, and quadratic is most suited summary for my work. So based on that, I will go for third one, transformation fit summary. Then third model, I will process for the quadratic options. So when you have to go for the quadratic options, then next was to check your data for ANOVA, analysis of variation. ANOVA is another method which can be says that your model is significant or not significant. It will give the value of f or p values. If your value, for example, this is one of the example is there, the f value is 12.57, that means the model is significant. And if this value is more than 0.05, that means your terms are significant. Basically these are the type of you can see calculation, but this software calculate, yeah, tested the ANOVA itself. You have to do nothing with that. In my case, it will give the f value is 0.03 and my model, quadratic model for the surface roughness, is significant one. And from the f value you can see that it can give this type of an 5.23 is the maximum factor. That means 5.23 corresponding to my depth of cut. That means depth of cut, it means the depth of cut is the most important factor which affect my surface roughness. And second one is 5.96, that is the combination of speed and depth of cut. So these are the two factors which affect my experimental work mostly. So depth of cut as well as the speed and combination of speed and depth of cut. So from that another term is r square term is there, which is predicted, or which is you can see that whether this is our data is desirable or not desirable. For example, this type of accurate precision one term is there if the ratio is more than 4 is desirable, and in my case you can see that it is 7.013. So that means the data given for the RA value is desirable in my case. So then next step, by using this design of experiment, it can give the intercept about the equation for true life and another type. That means the intercept means it will give the my array value that how much intercept of speed, feed and depth of cut and others are given, and from here I have give it into the form of mathematical equations. So these equations, these are the two type of equation. It will give into the two forms. One is coded form, second is in the actual forms. So surface roughness, that is in my case, yeah, in my mathematical model, this is the equation given by the software. 0.33 intercept, first interaction is 0.33, then speed is 0.13, that is for speed. For a, that is plus a plus 0.15, 0.2 into 3c. So this is the intercept which it is given. For example, b square is there minus 0.17, so b square here and minus 0.17. This is in term of actual coded, that is 1 or minus 1. And in term of actual factors, when you have to apply actual velocity, actual feed of speed, then this is the equation in term of RA value. So for RA, similarly, I have go for the third tool life as well as for my tool vibrations. Three terms are I have decided down. So second I have skipped out. Similarly, these equations for tool life is square root of tool life. This one surface roughness, that is, this will give into the quadratic forms. You can see that because my model was quadratic, I have selected which he has opted one. Second, for tool life, it will interactions of two factors, that means a into c or b. This is to the given the best options, so this is in the form of two factor forms. And third one, this is my vibration amplitude, it will suggest the linear model for that, and the equations I have found for vibration amplitude is in form of linear one. So these the three type of, you can say, these are my mathematical equations or mathematical model in form of, in term of, to find out the RA value, or you can see tool life as well as the vibration amplitude. So for another for after going innova, another test is, you can see that diagnose my result work. You have to see the tab of diagnose after innova. It will give out lot of plot. Mostly the normal plot of the residual is to be given. So this is the normal plot is given. How it is to be decided, I have to see that. So this is my work for my predicted as well as the actual work for in case of surface roughness. Surface roughness, you can see that there are some blue dots are there, some red blots are there, and some white dots are there. So these are the blue dots which is more close to the these fitted values. This is almost this range of the surface roughness are showed, or these are the required values. And red colors, these are the these values which are deviated from the experimental work. So but the mostly in my case, these are the in and around near about my actual middle value, and these values are acceptable one. Then this is the another type of plot which you can see from this design expert. This is known as boxcock plot. It can give, or it can find out the value of lambda. Lambda is it can search about the confidence level, on which you can see that in my case, if it is outer side minus 5 to 5, that is not desirable, but in my case it is minus 6.45, which is, that means no transformation is recommended in my experimental work. So then there are another these are the model graphs you can got from the this software. So these model graph of one factor, two factor, three factor response graphs are there. One factor in which, for example, in my case, this is one factor graph is there for speed versus RA value. You can see that on the x-axis this is speed is there, and on this is surface roughness is there. And mainly you can see that at the lower speed, if the cutting speed is below, the roughness is low. Then if the at middle it is higher, then it is low, but it is within our dimensions limits, resulting that this is also resulting the classical theory of my machining process parameter. So this is the one factorial method, yeah, or one factor of doing how to got that one factor graph. Another factor, yeah, another second variable was my feed. You can see that feed rate versus the um, surface roughness. Again, it will go, you can see that the feed and that depends upon, but it is remains almost constant, but these are again within the limits which maximum and minimum value, and these are the all acceptable. That third factor was of depth of cut. Depth of cut also they interpret that the if the RA value will increase if depth of cut will increase, and again it is within the limits are there. Then another, this is another graph which you can say that perturbation graph is there. This is not nothing, that this is the combinations of three factors into the one factor on in one graph. You can see A, B, and C. A is for you can see that it can show factor A is goes for shows for your cutting speed, B is to B is curve for feed rate, and C is for depth of cut. And C is, you can see that the deviation of C curve is much more than A and B. That means the depth of cut is mostly influence your surface roughness parameter. So this is these are the graph which I have converted for only surface roughness. Similarly, you can go for another type of for my tool vibrations as well as for my tool life also. So this is then response surface graphs are there. Response surface graphs, it will gives you the in the graphs in the 3D form. Which 3D forms you can go for the model graph, then 3D surfaces, and 3D surfaces it will give the surfaces into the 3D forms. Yeah, this is analysis. Then I will go for the अगर लास्ट टाइम अगर बस 2 मिनट में कर देता. हाँ जी. So these are the graph how we'll have to graph for the 3D graphs. This is the graph speed versus feed and depth of cut, and this is all. This is one of the graph I have made, the speed on surface roughness tool and tool vibrations. This is the analysis for that. This is on how the effect of on tool life and what is my tool vibrations are that. And this is for last one, the whether your solution is how to optimize that solution. Optimization solution, it will go for, you will go for a ramp graph. Ramp graph is it will by giving this type of, for example, speed, feed, and depth of cut, you have to cap your speed in range, feed maximum, depth of cut minimum, surface roughness of the objective you have to give minimum, maximum, and in the range. By giving this, it will give us this these parameters, that these are the he has suggested two optimum result. One is in this factor desirability is 0.5, and second this is 0.556. I have selected one of them and validate my results. You can see that the predicted value and actual values, the residual work is like that. From here you can see that I have optimized my work for maximum tool life and minimum surface roughness. When I have to use this cutting speed given by the software, it from here I have to see that the surface roughness is improved by almost 11.57 from the predicted values, and tool life is improved by 11.48, where the vibrations I have found to reduce by 8.77. So these are my outwork or from that. And this is you can see that from one of the paper in the Journal of Optimizations in Hindi publications, minimization of surface roughness. Thank you. If you have any questions, please. ਹਾਂਜੀ
ज़्यादा questions नहीं, answers तो तुसी दे देंगे. So well, thank you, Mr. Sukhdev Singh, for the very nice presentation. He has highlighted how he has conducted his study, what were the independent, dependent variables, and what type of statistical techniques he has used. He has in this he has used ANOVA, multiple regression, like that. These things further will be discussed on Thursday next week also. So I will like to, means if anybody has questions on this, we can have little bit of that. I think D.A.V. Institute of Engineering must have by now joined the center. Hanji, D.A.V.
Madam, this is from Civil College of Engineering.
मैंने डीएवी का ही करेगा ना, फर्स्ट डीएवी से शुरू जो मैं सेंटर बोलूंगी ना, वी विल हैव सम इंटरेक्शन फ्रॉम देयर एंड देन वी विल सी. फर्स्ट ऑफ ऑल वी आर टेकिंग अबाउट द डीएवी इंस्टीट्यूट ऑफ इंजीनियरिंग एंड टेक्नोलॉजी जलंधर. ये डीएवी वाले ही है. हाँ जी, एनी क्वेश्चंस प्लीज. आपके भाई 20 लोग नहीं दिखाई दे रहे हैं मुझको. हाँ जी, इफ यू हैव एनी क्वेश्चंस यू आर वेलकम. इसको फिर किस तरह के क्वेश्चंस तो आप ही देंगे, मैं इधर हो जाती हूँ. ठीक है, आ जाओ. Okay, that's okay. It was just in the lighter vein because earlier 2 days there were such problems. So any question from this end? No question. I move to YMCA. YMCA University of Science and Technology फरीदाबाद. आप ना आगे करते जाओगे फिर जैसे बोल रही हूँ.
Yes, ma'am.
Any
Hello.
question please? Any question please?
No question, ma'am, right now.
ये YMCA का.
हाँ जी.
Then I move to this Andhra Pradesh, Vijayawada Institute of Technology and Engineering, Vijayawada. PVPS Institute of Technology, Vijayawada.
Good morning, madam.
Yes, sir.
I'm Shriram Vikas.
Yes, sir. Any question, please?
Yes, madam. I have a doubt in 3 level and 2 level. Difference between 2 level and 3 level.
It is very easy. You can see that my slides are there. 2 level is when if
Why we use 3 level, sir?
if the number of experiment you have conducted in case of 2 levels, the number of experiments are limited up to the you can say 8 or 16 to the power n. And in case of 3 factors, you can see that the experimental work will be given by the 3 raised to the power 2, 3 raised to the power n, and you have to find out the more results, more accurate result by giving the 3 level factorial. 2 level one, I will explain you what is the 2 level or 3 level earlier. 2 level, for example, temperature, I have 2 levels, low level and well as high levels. And 3 levels, if I say that cutting speed is 3 levels, one is low level, one is middle, and one is higher, that is the 3 levels.
Temperature also can we make?
It can be used. It can be used. That low. It can be decided by yourself whether I have to go for two level or 3 levels.
But more accuracy we will get in 3 level, right?
It's 3 level. 3 level.
Okay. Thank you, sir.
Okay. Very nice that you have listened to it with keen interest and raised certain questions. Sir, I am just wondering, you have given us the list of more number of participants, but I am not able to see that much in this center.
There
are 14 participants. Perhaps all are not present today. I can watch only. अब enter हो रहे हैं. अब इन्होंने तो miss कर दिया direction. They have missed it.
10 are there.
2 have just now joined. Okay, thank you, sir. Let me come to the next institution, Gandhi Academy of Technology and Engineering. Yes, sir. Any questions, please?
Yes, ma'am.
Yes, sir. Any questions?
Can you able to hear me, madam?
Yes, we are hearing you, sir.
Good morning, madam.
Good morning.
I found sir's work is a very nice work. Thank you, sir.
Thank you.
But one thing, I just have some doubts in that, because I am from computer science department, so there are some, you have shown one framework. By framework or the flow chart, you have defined the stepwise how you have to go and how to decide. So this is generally, we are, when doing our research, you are designing the framework or a flow chart. we give a proposal or our area of work is how to design a flowchart for a particular work. So in that,
This
yes,
is the general flow chart you can
yes,
make
sir, yes,
for
sir,
any
yes.
experimental work, and this is the flow chart I have chosen to design an experimental work
Fine, sir, fine.
as a
I
hard
understood,
design
sir.
expert.
This is fine. I understood, sir. But
Uh,
this is sometimes you have to validate that chart
yeah,
so that
valid.
you have adapted one. You are not. You have to validate who
Yeah,
designed that chart.
validate the result when you have to come out. The optimized results are with you. Last
Yeah,
time you can see that optimized results are there, then you have to validate your experimental work on that optimum values or that optimum parameters
thank
only.
you, thank you. Yes, okay. I am coming to your work. So when you are taking the minimum, maximum, and the middle value, three values you are taking.
Here I have taken the minimum value of for go for my slide. This is for cutting speed. I
Yes,
minimum is
I
100.
understand.
Yeah,
But when by taking these three, what
yeah.
is the criteria to take the minimum? Because
So
when I going for
this
the
this is
one,
the criteria. This is you have to choose in what type of the material you have to machining for, and that criteria or that machining parameter will be given from the any design data book or from the past literature work.
okay, but when we are taking for this academic assessment, you
Yeah.
are taking minimum five states, very
Mi-
good, good,
mi-
bad, and excellent. Like this, minimum five stage you are taking to analyze. Madam, I think I am clear about that because five minimum level we are taking. But how in a experiment by the minimum three you can come to a conclusion? Because when you take five,
uh, it depends upon the nature of the experiment. Even if he has taken the three readings, he can come up to that. Of course, if he could have gone for the more number also, but even
the
three
cost
will
of
suffice
experiment
also.
will also.
but
Other
then
other factors start coming in, and
very
I think if the three are coming quite close to each other, then there is he can, and the cost and other factors are there, then he can stop it there also.
okay, thank you. Madam, when we have to design a flowchart, because I am coming to my area of research, so
Yes.
how I will take this dependent and independent variables?
It
When
depends.
Hello,
I just offhand I
madam.
can't just say these things, because maybe in certain disciplines you have that type of thing. But say here he was saying that there may be other variables which are affecting, but I have not taken care of. It means there is some scope you define for your research. You
Mhm.
cannot take everything in one piece of work. Certain things are left for the
Hello,
further research also.
madam.
Okay, thank you,
Madam,
thanks.
we are from TIT College, Bhiwani. Madam,
हाँ जी सर.
hello.
हाँ जी सर
I'm
बताइएगा.
Dr. K. Chatterjee from TIT College, Bhiwani.
Yes sir.
Although, first of all, I'd like to congratulate the very good work he has done. But the question is how he has selected these levels, three levels, whether the practical point of view it is useful or not, if that can be covered. And another work, suppose there are various kinds of design of experiments techniques. There are some comparative studies, if it is can be made, so that can be shown to us,
I
madam.
understand there could have been examples from each disciplines who have joined this, and there, because just now when he was talking about the independent and dependent variables in the case of computer science, say when you are developing any new software, the things may be of different type. When we
Right.
come to these type of things, there were we talking of temperature, pressure, and he was talking that certain other materials can also affect his results, and to
Yes.
some extent he has control. So these things may differ from discipline to discipline also. So you
Yes.
just,
Yes.
we can't have means one answer for all disciplines for all types of experience experiments also. Here
Right.
he
That's right.
has
That's
taken
right.
three
Yes.
things and manipulated all of them. It might have been there that he is just taking three variables and not manipulating further them. Only at one stage the experiment is conducted. So the researcher decides what will be the scope of his work. right? So that will put certain deadlines on this. Point is, it's not that what type of limitations you may say or controls are there. Point is, whatsoever you are doing, under what conditions you are doing, you are to write those things in your research report, so that, because when we said that good research is which later on anybody can verify it, say he has done some work taking those aspects only, and under those conditions, if any other person in mechanical engineering wants to verify those results, he will be able to verify those results. So point is, whatsoever are the limitations.
Madam, how you have
Yes,
selected
sorry.
the actual level to be answered? The selection of levels, actual levels.
Creation of
I,
my three levels factorial can be done. This is not I did experiment work directly on these materials. I have conducted some pilot or a run before starting the actual machining. Second, I will take the data from the past literature work as well as the handbook data of the this machining research work.
Thank you.
Thank you.
Thank you. Thank you, TITS Bhavani, from there. Let me now come to the last question. And for that, I will be inviting Government Engineering College, Bharatpur. Government Engineering College, Bharatpur. सर आपके लोग तो बहुत कम हैं, मुझे तो आपने 30 की लिस्ट भेज दी थी.
Yes,
Any
ma'am.
question first? Okay. Any question first of all, sir?
Actually, ma'am, I want to ask one question only.
Yes, sir.
Ma'am, there are limit of minimum and maximum limits are taken by the experiment in the experiment. How we can decide minimum and maximum limit? Can we expand these limits?
Sure.
Yeah. For example, I have taken the cutting speed. First variable is my cutting speed. I have taken the minimum limit. Minimum minimum limit is 100 and maximum limit is 180. Beyond, if I taking the beyond 180, my experimental work doesn't work because my insert cannot be worked about that, and about 100 minimum it will take more time. That means my experimental work I have to fix my constraint something below, and one is the maximum. Before 180 I can find out my tool life is almost negligible, or experimental cannot be worked on, so I have to limit that one. One is the lower one and another is higher one. Then accordingly from the literature review and by giving the trial run, I have estimated my levels.
So, sir, this is in literature that the maximum limit is 180. After that, the tool is not working properly.
Yeah, no, it will work, but my tool life will decrease.
Thank you, sir. Sir, just a minute with this institution. सर आपका मुझे आपने 30 की लिस्ट भेजी है, तो इस वक्त कितने लोग हैं वहाँ पे?
Ma'am,
मुझे 30 तो नहीं दिखाई दे रहे हैं.
30 is not there. Currently, we have only 20 participant here.
हाँ जी, तो 20 हैं, तो बाकी को फिर सर्टिफिकेट्स कैसे मिलेंगे? आप मुझे ये जो 20 इस वक्त है ना, उनकी लिस्ट भेज दीजिए.
Okay, ma'am.
हाँ जी, thank you, sir. Let me move to this. Thank you, Mr. Sukhdev, for being with us for this a very interesting session. Let me now request Mr. Gaurav Gupta. He will be taking a topic from civil engineering department, civil engineering area. He is also pursuing his PhD in our institution and has done and published papers on his research work. आइएगा please, sir.
Madam,
Thank you. Thank
Excuse
you.
me, madam. Excuse me,
Yes, sir. Yes, sir. Please.
This is from Sukhdev College of Engineering.
हाँ जी, sir.
So I just want to ask you that is it because we are participating in full numbers we are not able to interact? Is it I mean discredit
नहीं,
for
आप नहीं. If you look into the things, at some point of time, I am giving chance to one center, and at some point of time, I am giving chance to another. But definitely, if you have, you can ask the question. That's no limit. हम थोड़ी सी tea time से quiz कर देंगे, हमें क्या फर्क पड़ता है? Doesn't matter. I welcome you, and I am happy that you have raised the question. Yes, sir. Please. हाँ जी. ये कौन सा सेंटर है? गांधी। सॉरी सर, आइएगा प्लीज, आस्क द क्वेश्चन।
Yes, please.
हाँ जी सर, क्वेश्चन। Are you hearing me? Are you hearing me, sir? Am I audible?
It's okay, madam. We don't have any questions as such.
Me, madam.
Okay.
Thank you.
Any other center who wish to ask any question?
Yes, madam.
हाँ जी आइएगा।
This is from Vijayawada, madam.
हाँ जी सर बताइएगा।
Sir, once go to that EN31 tool, that slide, sir. That composition.
That is the general composition of EN31.
Sir, if we want to make different compositions, we want to make a composite. Some 6 elements are there. Actually, that is the generalized one. Already it is there in data book.
Yeah, this is the generalized one.
New material if you want to make in composites. So what combination, which levels and which factors we need to take, sir? If 6 elements are there in that.
So
that
you have first you have to decide what type of composite you have to make, what type of the strength or what type of properties you have to find out, and what are the constituents that make your variables. This is you have to decide what type of percentage of constituent you have to make it out to make a proper composite. So that
tell for EN31, sir.
Yeah.
It is already there, but for example, if these 6 elements are there, if we want to make this kind of composite, what levels you need to take, sir? Which is here iron.
So this is composite. For I didn't make for that. That is another area. For the composite, what are the most I can see that the carbon or silicon, or which are the factor, which are the elements which affect the properties of the composite, that I have to take about that for the consideration for making the composites.
Thank you, sir. Any question, so that we move to the second presentation? Okay, if no question, let me request Gaurav Gupta to. हाँ जी sir, हाँ जी।
IC group of institutions, Greater Noida.
हाँ जी सर आइएगा, हाँ जी बताएं।
I have one question.
Yes sir. हाँ जी, डॉक्टर संतोष कुमार जी हैं। Hello.
CNC milling. Hello.
Hello sir.
The title of this research is minimization of surface roughness and tool vibrations in CNC milling machine. Hello.
हाँ जी sir, we are hearing you.
Okay. All the parameters related to surface roughness and tool vibrations are same. Even tool vibration is responsible for surface roughness. So why we are having this this large title? Can we reduce this title to minimization of surface roughness only, or minimization of tool vibrations only in CNC milling operations?
My objective was to minimize the surface roughness and tool vibration, and to increase the tool life also. That I had already eliminated in that one, but it can be there. The minimization. This is the 2 factors. When I have to optimize my work, I have to given for keep my surface roughness should be minimum and tool vibration will be minimum. I didn't consider even tool life and another type that can be operated. This is up to the you can decided whatever the experimental you have to done that.
I think, sir, surface roughness is based on tool vibrations.
Yeah.
So all parameters you have taken is responsible for tool vibration. And
tool vibrations, that is tool vibration is combinations of feed and depth of cut, and surface roughness mainly depend upon the cutting speed. That is why I have to take in surface roughness as well as the tool vibrations.
Okay, thank you.
ओके थैंक यू सर। आपके सेंटर में पूरा दिखाई नहीं दे रहा हमें, आपका सेंटर पूरा, आपके कैमरे का थोड़ा सा। हाँ जी, तो लोग तो 3 ही बैठे हैं। आपने तो हमें लिस्ट लंबी लंबी दे दी। आप मेरे को, आप सर कौन आपने जिन्होंने क्वेश्चन पूछा उनका नाम क्या है? मुझे आप अपने नाम बता ही दें. आई एम सीइंग ओनली 5 पीपल सिटिंग देयर. आप मुझे ये 5 लोगों के नाम भेज दीजिएगा. जो 5 लोग बैठे हैं उनके नाम भेज दें मुझे आज. May I know your name, sir?
My name is Mukesh Kumar.
Kumar. You are from IEC Institute, Group of Institutions, Noida. Am I right?
Yeah, ma'am.
Thank you, sir. Thank you, and you have raised very good questions. You are right in saying हम generally चाहते हैं कि title of the research जो है that should be small, but at the same time it has to convey what is being going to be done. So जो major variables हैं जो इन्होंने point out किए हैं सुखदेव जी ने, that had to be shown in the research title also. Thank you, sir. And now we move to the second presentation. Thank you, sir.
Okay, thank you. Mute कर दो. जी. और बैठे.
Good morning to all faculty members and the participants of the program. I am here to give a study on experimental research in civil engineering. The topic of my research is effect of fiber length on polyester fiber reinforced soil. This is a paper I published in USA in the University of Nevada in March 2016. Coming on to the introduction part. Randomly distributed fiber soil comprises of soil mixed with fiber arranged in a random position. So first of all, we need to know why are we mixing fibers in soil. These fibers are mixed in soil in order to increase the shear strength and the tensile strength of soil. Randomly oriented discrete fibers improve the load deformation behavior of soil through interlocking and through surface friction. Fiber reinforcement works as a tension, resistance and as a frictional element. As we can see here in the picture, a road comprises of various layers. This is a typical section of a flexible pavement. In this, there is the lowermost layer is a subgrade layer which we are trying to improve upon by adding fibers. We have chosen polyester fiber over here. Polyester fiber is a synthetic fiber derived from air, water, coal and petroleum. Polyester fiber used in this research is manufactured by Reliance India Limited under the brand name of Recron R3S. Some properties of these fibers are shown here. The shape is triangular, effective diameter is 10 to 40 microns, length 6 and 12 millimeters. Both the lengths are used in this investigation and effect has been studied and compared. Specific gravity is 1.31 to 1.39, melting point 150 degrees Celsius, tensile strength 4.6 MPa, and Young's modulus is greater than 5000 MPa. The purpose of this research. The purpose of this research is to examine the effect of fiber length on polyester fiber reinforced soil by conducting California bearing ratios tests. So first I would like to come to what are the main elements in this research, what are the variables, independent variables, dependent variables and extraneous variables. The length of polyester fiber used in this research is of 6 mm length, and 12 mm length. Objectives of research. The first objective is to determine the influence of content of polyester fiber on various lengths 6 mm and 12 mm to find out the maximum dry density of soil and the optimum moisture content. This study is done on two kinds of soil in order to cover the wide aspect ratio of various kinds of soil available in India, one being sand and other being clay. To find out maximum dry density and optimum moisture content, we are doing modified Proctor compaction tests. Second objective is to study the effect of percentage content of fiber of various lengths on California bearing ratio, both soaked and unsoaked. Again on both types of soil, sand and clay. Coming down to the materials used, types of soil used, one is sand and one is clay. Experimental program involved in this research. First, we classify the soil based on IS 2720 part 4 and 5. By doing this, we came to know one soil is sand and one soil is clay. Next, modified Proctor compaction tests were done based on IS 2720 part 8. And thirdly, California bearing ratio test was done on code name is IS 2720 part 16. This is a typical testing machine of California bearing ratio test. This is a strength test in which we come to know how much the strength of soil has increased, which will be used in the subgrade layer of road. This was first devised by engineers of California Division of Highways in 9 years from a period to 1938. This is the most universally accepted pavement design method. It's a standard penetration type load deformation test carried out using values obtained from the test from an empirical design chart. The pavement thicknesses are calculated. The specimen for the test may be prepared in the laboratory or can be taken directly from the site. The mold of the specimen has following specifications. One, diameter is 150 mm, height is 127.3 mm. There is a separate base plate and there is a collar plate. The specimen is soaked and the expansion of the sample is also noted. The load is applied through a cylindrical plunger whose diameter is 50 mm. The rate of penetration is 1.25 mm per minute. As the piston penetrates the soil, corresponding load is noted. The first load is noted for 2.5 mm penetration, whereas the second load is noted for 5 mm penetration. Now this load is expressed as a percentage by dividing the load to a standard load given by the designers of the experiment. As you can see in this figure, these are CBR molds which are soaked in water. The reason of soaking is to provide adverse moisture conditions to the road. Due to heavy rainfall, the subgrade soil would get submerged and this would lead to low CBR values. Hence, to counter this effect, we soak our samples for 4 days in water and then we take the readings called as soaked CBR readings. This is the CBR equation, which is 100 x by y, where x is the load at 2.5 and 5 mm penetration and y is the standard load of crust stone given by the designers of the experiment for 2.5 mm and 5.0 mm. Typical ranges of CBR value can be seen from this chart. As gravels are strong and the particle size is high, CBR ranges from 40 to 80. Whereas for poorly graded gravels, it is from 30 to 60. Similarly, for sands, well-graded sands have 20 to 40 CBR, or sands with fines have 10 to 40 CBR. In case of silt and clay, CBR considerably falls, and it ranges from 5 or less for OL soils, and for MH and ML it is 10 and 15. This is the basic line diagram of CBR test. As you can see here, applied load is applied through a standard plunger on this soil specimen. Two readings are taken, one for the load and second for the displacement. On the right side you can see California bearing ratio graph on which the effect of moisture content of CBR on CBR is shown. This is a modified Proctor compaction test. In this test, to perform a CBR test, first we need to know at what density are we going to fill the soil. For this, we need to perform modified Proctor compaction test. In this test, moisture, as you can see, there are 5 readings on the curve. Moisture is increased and corresponding density is noted. In this test, in a mold, we fill the soil in 5 layers by giving 25 blows to each layer, and the corresponding density is noted. The volume of this mold is 1000 cc, and hence we find out the maximum density which can be achieved. Now the CBR molds are filled at 97% of this density. The reason being that to achieve 100% density is not possible on field. Now I would like to come to the experimental part. Fibers are proportioned based on literature review of other researchers. These are the proportions of fiber: 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1.0% by weight of dry soil. Dependent variables. Now coming to the variable parts, there are 3 types of variables: dependent, independent, and extraneous. A dependent variable is the one what you measure in an experiment, which is affected during the experiment, which we are trying to find actually. It is a variable whose value depends upon independent variables. Whereas independent variables, as the name suggests, is a variable that stands alone and is non-changeable by other variables. We have full choice of selecting the independent variables we want in a study. So in this study, independent variables would be soil. Coming to the type of soil, clay. Second type of soil, sand. Similarly, another independent variable is polyester fiber, one being 6 mm length and second being 12 mm length. As you can see, we have full choice of selecting these materials, and independent variables can be increased or decreased in order to cover the scope of work. Dependent variables would be maximum dry density, optimum moisture content, and California bearing ratio value. These values we are trying to find out by changing the independent variables. Third and the most important are the extraneous variables. Extraneous variables are undesirable variables that influence the relationship between the variables that an experimental examining. The influence of the outcome of an experiment through these variables are not of any interest otherwise, but they affect the main dependent variables. So in this study, these are the extraneous variables. First, improper mixing of fiber. If the fiber is not mixed properly in soil, there can be accumulation of fiber at one end of soil sample very high, whereas some portion of sample might be deprived of fiber. Second, improper compaction of soil. Soil needs to be properly compacted and uniformly compacted. Third, unskilled labor who doesn't know how to work properly with the soil. Next would be poor quality or contaminated water for soaking, which might, if some chemicals are present, there might be some reaction of water chemicals with the soil, which can lead to hazardous results. Improper shape or poor condition of molds of CBR in which soil will be filled. Using of non-calibrated dial gauges for load proving ring and for displacement ring. Laxity on the part of observer while noting down the readings of the experiment. He might not see the right displacement for the corresponding load. Improper calibration of load and displacement dial gauges. The period of soaking for CBR is 4 days. It should be very proper, and proper notice should be given to the observer when to take out the samples from water. In case you exceed for more than 4 days, like 6 hours or 8 hours, in case the lab is closed or there is some other problem, then the values would be changed. Now coming to the results and the observations of our research. Here we will study the effect of fiber length on maximum dry density in case of sand first. Maximum dry density, as we can see, is first shown for 6 mm length fiber, now for 12 mm length fiber. As you can see, the highest density is achieved at 0.3% fiber. Similarly, for fiber length in case of clay, The maximum dry density is achieved highest from 0.1 to 0.4% of fiber. Now comparing two different types of soil on the same graph, you can see maximum dry density of sand is 2.07 gram per cc, whereas for clay is 2.04 gram per cc. Effect of soil on maximum dry density with 12 mm fiber length. For sand, highest density was achieved at 0.3, whereas for clay, it was achieved from 0 to 0.4. Now the next part to study is optimum moisture content. We can see a small but a gradual rise for the optimum moisture content in case of sand. Secondly, for clay, the rise is a bit higher as compared to that of sand. Highest optimum moisture content of clay was noted at 1.0%, and the values were 11.5 and 11.4%. Similarly, effect of soil on optimum moisture content with 6 mm fiber was for again 1%, and the value was 11.5 and 12.2. Comparing the results of sand and clay for 12 mm fiber, we can see that the highest value again comes at 1%, giving similar results in both the soils and both types of fiber. Coming down to the last experiment, that is a California bearing ratio test. This is a strength test. The whole aim of our research was to improve the California bearing ratio. Once the California bearing ratio is improved, the upper layers of pavement, namely granular subbase, and bituminous concrete, their thicknesses can be reduced. Due to reduced thicknesses, there would be a higher economy achieved, as these layers are very expensive and costly as compared to the subgrade layer. So now, as we can see, by adding only 0.1% fiber, we have 12.4% CBR, but on adding 0.4% fiber, the CBR increased to 36.8, nearly around 3 times in sand. But the increase in clay is not as much as in sand. The reason could be the frictional resistance developed by sand when interlocking of granular particles. The particles of clay are very small, less than 2 micron, and also there is, due to plasticity, the clay is very weak in CBR. But in sand, due to proper interlocking, high tensile strength was developed with fibers. This is a variation of unsoaked CBR. As you can see, the values are higher for unsoaked than for soaked. In this, 55.5% of CBR was achieved for sand in unsoaked conditions, and 17.5% of 17.5% CBR was achieved by adding 0.5% fiber in clay. Now coming to the 6 mm length fiber, like in this case 25.9% CBR was achieved for 0.1% of fiber, and 4.6% CBR was achieved in clay for again 0.1% fiber. Yes, so closing it. Similarly, you can see the same behavior for unsoaked clay. Conclusions. Key findings. Sand when impregnated with 6 mm polyester fiber yields highest maximum dry density of 2.07 gram per cc. This was achieved at 0.3% polyester fiber by weight. Lowest value of maximum dry density was achieved at 2.0 gram per cc at 1% polyester fiber for 6 mm length. Sand when impregnated with 12 mm polyester fiber yields highest maximum dry density of 2.06 at 0.3% polyester fiber by weight. The decrease in polyester maximum dry density could be because of lower specific gravity of fiber, and also due to balling and curling effect of fiber when the fiber content is excessively high. Fiber intermingles with itself and forms small balls, due to which sand is not able to mix up uniformly, and hence some portions of sand is and some portions of fiber are distributed ununiformly. Key findings. Again, clay used in this project achieved maximum dry density of 2.04 gram per cc, and this remained constant until addition up till addition of 6 mm and 12 mm polyester fibers at 0.3 and 0.4% by weight of soil. The lowest value of maximum dry density obtained was 2.02 gram per cc and 2.01 gram per cc when 6 mm and 12 mm fibers were added, and this was gradually increased from 0.8 to 1% and from 0.9 to 1% polyester fiber by weight. Coming to the optimum moisture content, the maximum value was achieved at 12.2% and 12.4% at 1% polyester fiber in case of sands for 6 mm and 12 mm fiber length. In case of clay, it was 11.4 and 11.5 at same dosage. Now, the main part of the research, which was CBR, which we are trying to improve. Addition of 0.1% polyester fiber yields to of length 6 mm yields to soaked CBR of 25.87 and unsoaked CBR of 40.35 in sand. Increase in fiber content decreased the CBR in soaked and unsoaked conditions to 14.38 and 25.78 at 1% fiber. Similarly, for sand and 12 mm fiber, and decrease of CBR value in soaked and unsoaked conditions to 14.38 and 25.78 at 1% of fiber. Thank you.
Thank you, Mr. Gaurav Gupta, for a very systematic presentation. I think you must have also come to know with this thing that what were the steps in the conduct of the experiment, what were the independent variable, dependent variables, and in addition you have seen how to reach at the conclusions, and which are to be also written in your research reports. So, well, if there is any question from any, now I am open. Any center can come forward for any question. Yes, please. हरजोत किन्नी सेंटर को आप इनवाइट एनी सेंटर हाँ जी सेंटर का नाम दस देना कोई सेंटर नहीं एनी सेंटर who will like to have any question, please?
Hello madam, this is from YMC University.
Yes sir.
Yeah, question. Hello ma'am.
Yes sir.
I am Emil Agrawal from YMC University.
Yes sir.
So was this research practically implemented anywhere? It was a good finding.
Yes sir. Sir, up till now, polyester fiber is used in concrete as manufactured by Reliance Industries. In concrete, is it used to take up the tensile cracking of concrete. But up till now, only propylene fiber has been used in soil. So this is a new fiber which is used in sand and clay. And looking forward to the implementation in field, I would like to proceed my PhD work. After which I would like to use this in field as well, because this would give us much more economical results and much more economical results and much higher strength in rutting life and fatigue life of the pavement.
What was the approximate reduction in cost by using this technique?
Sorry, what was the, sorry sir, can you repeat?
What was the approximate reduction in cost?
Reduction in cost, sir.
Yes, yes.
Yes, sir. So reduction, like as you can see that if pavement CBR value is increased up to 4 times, so reduction in cost is assumed and approximated to be around 4 times. Thicknesses of layer is reduced, and it depends upon the current construction cost of those layers. But one thing is sure, that the layer thicknesses will reduce by 50% on improving the CBR by 4 times. So a study can be made on how much exactly, what is the statistical what do you say, the budget and the cost analysis of the road, and how much thicknesses can be would be reduced, and then how much savings would be made.
Thank you very much, sir. Thank you.
Thank you. Let any other center who has any question regarding this experimental study. Any other center, please?
Hello.
Yes, please. Yes, please.
Dronacharge College of Engineering, Gurgaon.
Yes, sir.
First question, ma'am, how to mix fiber with the soil?
Yes, in this case, we have mixed fiber with hand, because mixing of fiber is a big problem because fiber tends to have a balling and curling effect. So in this case, we have tried to mix fiber with hand, but another way is to mix it in water first and then add to soil. But in my study, I have mixed these fibers with hand using proper labor.
That is it in solid form or liquid form?
This is a polyester fiber. Like polyester is nothing but cloth, like polyester filled pillows are there. So this is a form of cloth, you can say, small cloth, which is of 2 mm, which is of two lengths, 6 mm and 12 mm. And this is available as a product from Reliance. We have to buy it in packets. A packet is of 125 grams and costs around 47 rupees. But these can be availed at subsidized rates once we contact them for research purposes or for bulk purposes of construction.
Sir, is this fiber used in all courses, surface course, base course, sub-base course and subgrade course, or only surface course?
No, I have used this in subgrade. My research is limited to soil, and this can be used in bituminous layers wherever tensile cracking can occur. Bituminous layers undergo fatigue failure. Fatigue is nothing but tensile stress accumulated due to wheel load application. So a research can be made on addition of polyester fiber in bituminous mixes. As we have seen, propylene fiber and coir fiber have been added to bitumen in past. This also can be added to bituminous layer. But my area of research is in subgrade layer and in geotechnical engineering of soil. So I have improved the subgrade because this is the most economical layer, because we don't have to pay anything for soil. It is available abundantly, and we are trying to improve this in order to decrease the upper layers of soil, upper layers of payment.
Thank you, sir.
Sir, one question.
Yes.
So when you choose this problem, have you consulted with the Reliance so that yes, this area is one of the effective area to do research, or just you have choose as per your requirements?
No,
because they have already developed one product, and the purpose also for to preparation of road. So when you are taking that experiment, this is for your convenience, means for your interest, or that is for the industry requirement you have taken that product?
No, this is not for my interest. Polyester fiber is achieved. First of all, this is achieved commercially, so it is easily available to all. But they are using only in concrete. So my interest was why not to use it in soil, where when very small amount, 0.4% by weight is added, and such high strength is achieved. Up till now, major work has been done using only propylene fibers, but very less work has been done on polyester fiber. So I wanted to use a new type of fiber, but it should be also be commercially available and easily available, and it should be added in a very low quantity so as to reduce the cost. And one most important finding was the sharp increase in CBR. If there is no the increase is not high, then economy would not be achieved. So once the CBR value is increased substantially, our research is validated that okay, you add this much amount of fiber because we have achieved a high improvement in CBR.
Thank you. This is the only area or the scope of domain in which you can use this fiber. Only this construction of road or any other purposes. It can be a question of objective of research. So for building construction or for any other construction.
This fiber is currently being used in concrete. The main purpose of fiber is to overcome the tensile strains. As you can see, concrete cracks. So 12 mm fiber is used in mix design of concrete by Reliance, and 6 mm fiber is used in plastering of walls in mortar. All this in order to take up the tensile stresses. So wherever tensile force is acting, we have to limit the cracking. Maybe in case of soil, or in case of concrete, or in case of plastering. So this takes care of the tensile stresses in the by stabilization of the soil or by stabilization of concrete.
Thank you. Thank you.
Thank you. Very nice questions are asked. So we thank the participants from at the center. Any other question from any other center, please?
One more question, ma'am.
Yes, please.
If the CBR fiber percent is 0.5 and we increase by the 1%, then the CBR value increases. If we increase by 2% or 3% or 4%, then what will be the result?
Actually, fiber has very low specific gravity as compared to that of soil. So after 1%, it becomes non-workable because of bulking. As we try to compact the soil is not able to hold so much amount of fiber due to low specific gravity. Specific gravity of sand is 2.36, whereas of that of fiber is of 1.31. So you can see that fiber is almost half the specific gravity of sand. Even at 1.0%, it became non-workable due to bulking and balling effect of fibers. It was very difficult to mix the fiber and to distribute the fiber uniformly in soil because the amount of fiber became very high, and it was not able to intermix in soil and make a composite mixture. The soil was breaking from inside and it was not able to confine in the mold. Also, as we increase from 1%, economy will reduce as this fiber is pretty expensive as compared to waste materials. So we will be increasing the cost of our experiment unnecessarily. So one point was to keep the fiber content very low, or just 0.2, 0.3, 0.4, so that economy is also achieved.
Okay, sir. And one more question, sir. We are using 6 mm length and 12 mm length.
Yes.
Is this any diameter?
Yes, the diameter of the fiber is from 10 to 40 micron. I showed you in this slide. These are the specifications given by the company.
Okay. It 10 to 40.
As you can see here, as I told you, 10 to 40 micron is the effective diameter, and shape is triangular. So due to triangular shape, higher surface area of fiber is achieved. Specific gravity is 1.31, and it has a high melting point, 150 degrees Celsius. So it has good resistance to heat also.
Thank you, sir.
Welcome.
Thank you, everybody. If any questions more, or we disperse for the tea? Any question from any center, please? Okay, then thank you, everybody, and we are highly thankful to Mr. Gaurav Gupta for making nice presentation and responding to the various clarifications.